We know many things about the sun, but a lot of that knowledge has been gained very recently. Working out what makes the sun shine was a process of eliminating different hypotheses, ideas, until one was found that best fits the evidence. The Greek philosopher Aristotle believed the sun was made of ether, a perfect substance that glows forever. However, in 1613, Galileo Galilei observed sunspots on the sun, and these imperfections showed that the sun could not be made of ether. Coal was burned in steam engines to power the UK's Industrial Revolution. This made scientists wonder whether the sun was a giant lump of coal, but calculations showed that a sun made of coal would shine for less than 1,500 years, and this is a shorter time than recorded history. However, efforts to understand steam power led to the principle of conservation of energy. This led scientists to look for other sources of energy that could be transferred by light. Scientists like Hermann von Helmholtz believed the kinetic energy of meteorites, lumps of rock, colliding with the sun could be this source of energy. However, the total mass of meteorites was too small, and they were not moving fast enough to provide the required energy. Other scientists imagined that the sun was once much bigger, so that it only just fitted inside the Earth's orbit. But the gravitational energy released when it collapsed to its present size could only have provided enough energy for 100 million years, which was not enough time for the evolution of different species on Earth to have taken place. Then radioactivity was discovered, and Einstein showed that mass can be transformed into energy. This led scientists to work out that the sun is powered by thermonuclear fusion, though a fully formed theory did not appear until 1939. The sun is an average or medium mass star and is made up of about 75% hydrogen and about 24% helium. The rest is made up of other elements, such as oxygen and carbon. The glowing hydrogen at the surface of the sun radiates energy. About 40% of this energy is visible light, about 50% is infrared radiation, and the remaining 10% is ultraviolet. Earth's atmosphere absorbs a lot of this ultraviolet radiation. The ozone layer in particular absorbs most of the harmful ultraviolet. Stars are powered by nuclear reactions that release energy. Stable stars like our sun are powered by the nuclear fusion of hydrogen into helium. This makes the sun shine. It is so hot inside the sun that matter exists as plasma. Although the sun produces gamma rays, because of the nuclear fusion process, collisions with the plasma mean that it takes about 100,000 years for that energy to reach the sun's surface. In addition, because the energy is spread over a big surface, the temperature is lower at the sun's surface. The Earth orbits the sun at a distance of about 150 million kilometers, which is within the habitable zone. This is the zone where water can exist in liquid form. If it was hotter, the water vapor would never condense. If it was colder, ice would never melt. The sun has a mass of 2 times 10 power 30 kilograms. This is referred to as the solar mass, as it provides a simple way of comparing the mass of other stars to the mass of our sun. For example, a star with 8 solar masses would have 8 times the mass of the sun. The sun contains over 99.86% of the mass of the solar system, so it exerts a big gravitational force on the planets and causes them to follow nearly circular orbits.